Today we're going to be starting a new unit, and the unit is called Systems of Equations. This is our fifth unit, and it's going to be a unit that pulls in some of the things that we've done in previous units, especially the linear functions unit. So in this unit, we're going to be looking at a number of different things. First of all, we're going to be looking at what is a system of equations. We're going to look at how many solutions you can have and the different types of systems. We're also going to look at three different ways to solve systems of equations. We're going to solve graphically, so both by hand and with our graphing calculator. And we're going to solve algebraically, and you're going to learn two methods. One is called substitution, and the other is elimination. And then finally, we're going to pull everything together and do some problem solving with systems. Now, today we're going to just look at what is a system of equations, and we are going to do a little bit of problem solving, but ultimately by the end of this lesson, I want you to understand what a solution is and what it represents in the context of a question. So our first example here says that Simon and Sandy are walking on a running track. Simon starts at the starting point of the track and he walks quickly at a constant speed. And Sandy starts 180 meters from the start and she walks at a slower pace, but still at a constant speed. Now the graph that I'm going to pull up here shows the relationship between the distance and the time. And so just as a quick refresher from our last unit, if we're talking about distance and time, distance would be our dependent variable and time would be our independent variable. So just a little review from the last unit. So the questions we're going to look at below here. So we have this graph, and Simon had started walking. Simon started at the 0 point, and he's walking quicker than Sandy. So again, some review from previous units. Simon's walking faster, so you notice the slope of his line is steeper. Sandy's walking a little bit slower. So while she starts at a different point, she starts up here 180 meters away, she's walking at a slower pace. But at some point, these two people cross paths. And so we want to look at what that intersection point is. And so if we use our little magnifying glass here, that point is at 1, 200. So if we look here, we cross at time 1 minute at 200 meters. So then the question is, when will Simon and Sandy be the same distance away from each other? Well, we know that they're intersecting at 1, 200. And so when will Simon and Sandy be the same distance? When means time. And so if we look here, that happens after 1 minute. So 1 minute after they start walking, they cross paths. And so I want you to look at that 1 minute and again, look at the coordinate and see if you can see any correlation there. And then the last question says, at what distance from the start will they pass each other? Well, if we use our little magnifying glass, at 200 meters, they're going to pass each other. So again, think about that coordinate and what the significance is. So these 2 points intersect at 1, 200. And while that's just a coordinate, those coordinates have value based on the context of the question. So the 1 is the independent variable, and that represents time. So 1 minute after they leave and 200 meters past the starting point, they're going to intersect. Excuse me, I had to sneeze. All right, so now let's take a look at this in terms of systems of equations. So what is a solution to the system of equations? Well, if we look back at this question here, our solution, or the point where the two people intersected, was our solution. So 1, 200 was the solution to the problem. When are these two people going to meet? And so when we're looking at a system of equations, this is just having a graph and looking at where the 2 points intersect. And where those 2 points intersect is our solution. Now, it's important to note that in this unit, we're looking at systems of linear equations. When you get further into Math 20, you can look at other systems of equations. They don't have to just be two lines intersecting. We could be looking at a parabola intersecting with a diagonal line. In this case, this question would have two solutions. All right, but we're just going to look at linear systems of equations in grade 10. Now, if I want to know if something is a solution, I'm going to have to do some substitution. And whenever we do substitution or we do verifications, we always try to use something called left side, right side. So if I want to verify if something is a solution, I'm going to use left side, right side. So the question is 3 comma negative 2 a solution to the following system? Well, the only way that something can be a solution is if that coordinate makes both statements true. If it makes one statement true but not the other, it's not a solution. It has to make both statements true. So we're going to start with y equals 2x minus 3, and we're going to use left side, right side. Now, all that this is basically drawing a line down your equal sign, and the left side of the equation is the left side, and the right side of the equation is the right side. So LSRS, left side is y, right side is 2x minus 3. Then we do our substitution. Well, x is 3 and y is negative 2, so we sub in negative 2, and then we have 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. These are not the same, so this is not a solution. Now, we could stop there because as soon as it doesn't work for one, we know it doesn't work. However, we're going to check the other one as well. So we're going to do left side, right side, more just so we get some practice with verifying. Left side is a y, right side is 3x minus 4. And so our y is negative 2. And then we have 3 times 3 minus 4. So 9 minus 4 is 5. Again, this one doesn't work either. This is not a solution. So again, to be a solution, it has to work for both points. All right, let's take a look at a couple more problems here. So we've got a data plan question here. So it says a company offers 2 data plans, and the functions below represent the cost of the data plan related to the amount of data used. And using this information, we're going to figure out when the 2 plans will cost the same amount. So this would be a typical real-world problem. You've got 2 options. You got to figure out which one's better. But the best way to compare them is to actually graph them together and see when they end up costing the same, and then decide, well, which one makes more sense for me. So in order to graph these, we're going to make a table of values. And so we'll start off with plan A. So plan A, our x value and our y value. I've already got most of the graph drawn out here. Based on our scale here, we're going up by hundreds. So I'm going to start at 0, and I'm going to go 100, 200, 3, 4, 5, and I'll go up to 600. Okay, so I'm going to graph all of these. Now, I can plug these all into my calculator. I can go 0.02 times 0 equals 0. I can go 0.02 times 100 equals 2, and so on. And I can get those values that way. So I'm going to have 0, 2. I'm going to keep substituting in, so I'll save some time here. 4, 6, 8, 10, and 12. Okay, so I would have calculated these all on my calculator. Now, if I plot those points, I've got a point at 0, 100 is 2, 200 is 4, and I could plot them all, but I'm just going to jump ahead straight up to the 600. 600 is at 12. Okay, and then I would take and draw a line through those points. Now, for the second graph, I'm just going to erase what I have here and make a new table of values. For the second graph here, I've got 0.01x plus 5. Well, I know that my y-intercept is at 5, so I know 0 is going to be 5. But let's make out a table of values here. So again, I'm going to go 0, 100, 200. I'll go all the way up to 600. So 300, 400, 500, and 600. And again, plugging those in, I'm going to have 0.01 times 0 plus 5 equals 5. 0.01 times 100 plus 5 equals 6. And then I've got 7, 8, 9, 10, and 11. So again, I'm going to plot those points. So at 100, I'm at 6. At 200, I'm at 7. 300, I'm at 8, and so on. 600, I'm at 11. All right, so let's draw this graph or draw this line. So I'm going to draw through those points, and we can see that there's a point where these two lines intersect. Okay, and that point is right here. And that point is at 500, 10. Now, if you had your table of values side by side, you would also notice this, but just finding that solution isn't enough. We have to look at, well, what does that solution mean? So the solution is that coordinate is 500, 10. Well, 500 represents the amount of data used, and the 10 represents the cost. So at 500 megabytes, so at 500 megabytes of data, or after 500 megabytes of data, the cost for both is $10. So the solution is 500, 10, but when we're dealing with a word problem, we have to actually give meaning to those numbers. So the 500 represents our data, the data used in megabytes, and the 10 represents the cost. So at 500 megabytes of data used, the cost for both would be $10. So someone who's trying to decide on a plan is going to ask themselves, well, am I going to use more than 500 megs of data? If I am, then I'm going to go with a different plan. If I'm going to use less than that, well, then I'm going to stick with the cheaper plan. So this is just a way to compare which is the better option. All right, now let's take a look at another cell phone plan question. So a customer is comparing two pay and talk cell phone plans. The functions below represent the monthly cost of the phone related to the amount of talk minutes. And using this information, we're going to figure out when the two plans will cost the same amount. So notice there's a commonality here. We're looking for the intersection point is going to be when they are equivalent or when they're the same. Now this time we're not given any formulas, so we're going to have to think about where these numbers come from. So we're going to jump back to the last question and take a look what these said. So here we had amount of data used and cost. So the X represented our amount of data used and Y represented cost in dollars. So 0.02 would represent 2 cents. So plan A would have been 2 cents per megabyte of data. Plan B would have been 0.01x plus 5. So that would have been 1 cent per megabyte plus an initial fee of $5. So let's use that to answer this question. Company A is charging 30 cents per minute. And so if we think about our independent and dependent variables, our independent variable is going to be time in minutes. And our dependent variable is going to be cost in dollars. Okay. Now, company A is charging 30 cents per minute. Now, because cost is in dollars, we have to write our 30 cents in decimal form. So cost is 30 cents per minute. So 0.30x or just 0.3x. And plan B is charging $15 plus 10 cents per minute. So 10 cents per minute, 0.10x plus 15. And so those would be our $2 amounts. Now, going with a scale here, I'm going to set up my scale and I'm going to go up by tens. Now, I've already done this question. That's why I've got my scale picked out. Sometimes you have to do a little bit of guess and check. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 minutes. So 10, 20, 30, 40, 50. Again, you don't have to label every scale. And I'm going to go up by fives here. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, go on by 50, 10, 15, 20, 25, and so on. Now again, in order to do these questions, we're going to have to do a table of values, and I'm going to show you a little bit of a shortcut that you can use when it comes to doing your table of values. So first of all, we'll set up our charts. Oops. So with a little bit of a thinner line here. So we're going to set up our chart for the first one and our chart for plan B. All right, so plan A, we've got 0.30x, so 30 cents per minute, and plan B, we've got 10 cents per minute plus a $15 monthly fee. Now, again, you can calculate all of this out. We can also use our calculator to help us. So I'm just going to pull open my calculator and turn on the buttons here. Now, I'm going to type my equations into my calculator. So 0.33x. Now, I'm just going to type in the first equation so I don't have to worry about balancing or jumping back and forth between equations, but I also have to set my window settings. And so my window settings here are going from 0 to 100, and I want to go up by tens. So we've already gone and done a calculator lesson before, so I'm going to go through this a little quicker. If you need some refreshing on the calculator itself, go back and take a look at that calculator tutorial. So I'm going to go from 0 to 100, so I'm going to go from 0 up to 100, and I'm going to go up by tens. My y values, I'm going to go from 0 up to 50, and I'm going up by fives. And so now I should graph it, and it'll give me a visual of what my graph looks like. And so I don't want you just to freehand it. I want you to still have accurate values. So we can always go into our table of values, so second function table. But this is going up by ones. That's going to get a lot. That's going to take me a long time to go through. So I can either go in and change my table settings, or I can use the graph. I was going up by tens, so I'm going to start with 0 here. I'm going to go 0, 10, 20, 30, 40. I'll start there and see if that's enough. If not, I'll go further. And the other one, I'm going to go 0, 10, 20, 30, and 40. And I'll use my graph to get my y values. So using that trace button, I can type in 10. I can type in 0 first. So 0 is 0 and 0. I can type in 10. 10 is at 3. So I've got 0, 0, 0, 0. 10 is at 3. 20 is at 6. 30 is at 9. And 40 is at 12. So I had 20 was at 6, 30 was at 9, and 40 was at 12. So again, I'm going into my calculator, I'm typing trace, and then I type the number I want. Once I've hit trace once, I don't have to keep hitting trace unless I've changed a different command. So I'm just getting what those values are. Now for the other equation, I'm actually going to leave that first equation in there for now, but I'm just going to turn it off. So notice that the equal sign is no longer highlighted. I've hit the enter button, but I'm going to enter in my other equation. So 0.10x, or you could just type 0.1x plus 15. Always make sure that you're entering your data in there correctly. And there's my equation. I'm going to use the same method. So trace at 0. 0 should be at 15 because that was the initial amount. And that is my y-intercept, but let's see what the rest are. So at 10, we have 16. At 20, we have 17. So 15, 16, 17, and then we should be seeing 18 and 19 because there's a pattern there. So 18 and 19. Okay. Now looking at the data, we don't actually have an intersection point yet, but we can plot these points and go from there. So the first one, I have 0, 0 and 40, 12. So 0, 0 is down here. And 40, 5, 10, 15, 20. Let's see if I had a nicer number there. 12. I'll have to kind of estimate a little bit here. So 40, 12. There's 40 and 12, 5, 10, 5, 10, that's 15. So 12 is probably right in about there. Right now I'm just approximating, but I could draw my graph look something like that. Now, if I draw the other graph, I know I'm starting at 15. I know I'm starting at 15, so 0, 15, 5, 10, 15. But this one isn't as steep, and so we know if we were to follow that pattern, 50 would have been at 20. So I'm going to graph 50 and 20. So 5, 10, 15, 20. I'm just using the lines to kind of benchmark. So 50 and 20 would be about there. And I can sketch my graph again. And so looking at those there, it looks like my intersection point is going to be happening right around here. And so I got 10, 20, 30, 40, 50, 60, 70. Now my lines aren't drawn completely accurate, but it looks like it's somewhere between 70 and 80. So we can actually find out what that intersection point is on our calculator. So right here, I'm estimating that it's somewhere between 70 and 80. I'm actually going to, partly because I know what the answer is, but I'm going to estimate it's around 75. And I've got, it's somewhere between 10 and, or 20 and 25. So maybe I'm going to guess like 23-ish. Okay, those are just an estimate. So it's 75 and 23. My calculator, though, can give me an accurate answer. So when we get into these bigger numbers, sometimes our calculator will come in handy. So I'm going to turn on my graph. Now I have both equations. I'm going to graph them here. And if I want to see where that intersection point is, I'm going to go second function trace. Notice right above there it says calc. So second function calc. And I'm going to go down to number 5, which is intersect. And it's going to actually tell me the intersection. So you'll notice that when I'm graphing here, I've got y equals 0.3 to the x, and they're saying first curve. The calculator is asking, do you want me to intersect with this line? And you're going to say yes. So hit enter. And then they go to second curve. Notice the equation has changed at the top. Now they're saying, do you want me to intersect that line with this line? And you say yep. Then they're saying, do you want us to actually figure it out? And you say yep. The calculator is not really guessing. That's just what the command says. But notice the intersection is at 75, 22.5. So that's our actual answer. So I'll go through that quickly again. Second function trace or second calc, 5 for intersect. So you can just hit the number 5 and enter, 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 and you have your answer. So our solution to this question is 75, 22.5. Now again, that's just a number on a calculator. The calculator doesn't understand the context. Your job is to interpret those values. So after 75 minutes, so at 75 minutes of talk time, the cost for both will be $22.50. So if you're someone who talks more than 75 minutes in a month, then you might want to consider the blue plan, because while you pay an upfront fee, in the end, that plan will cost you less than the 30 cents a minute. And so it's really important as a consumer that you know how to figure out some of this information, because it may benefit you to do some of this calculation when you're trying to choose plans. All right, so those are the examples I have for today. Tomorrow, we're actually going to look at graphing and solving by graphing, and we're going to look at doing that both by hand and with the calculator. But this is just a little introduction to systems of equations. We'll see you soon.